Hello and welcome back to the lecture on applied econometrics. We have been talking about autocorrelation, and in the previous lectures we have seen different tests of autocorrelation. Now in this lecture we are actually going to see data. We will be using both stata and R, and we will see how autocorrelation looks like and how we are going to use different tests to determine the autocorrelation. And finally we will also talk about how to actually deal with autocorrelation. So we know that autocorrelation is there and we know it's a problem. But so what? How can I actually, make my model free of autocorrelation? So these would be our topics in this lecture and in next couple of lectures. So let's start with how can I visualize from data if autocorrelation is already there or not. Okay. So let me actually first start with my stata. So I'll be showing you a data set that is about US consumption data set. So let me import, it is in Excel format, and I need to give it the path, this one, table 6.1 Excel file. So let me open it. So now I can actually visualize this data, and I can, we'll explain this data set. So we have year, we have consumption, we have income, we have wealth, we have interest rate, and then we have, these are the main variables we'll be using: consumption, income, wealth, and interest rate. And then we'll have this log of consumption, log of disposable personal income, log of wealth, and then difference of log of consumption. I'll explain this D part later on. D log of disposable personal income, D log of wealth, and D of interest rate. So I'll talk about all these different variables. Essentially the point is we have these 4 different variables which we are going to work with: consumption, income, wealth, and interest. Now, for some reason it seems that data for year is not in the right format. So let me do one thing. Let me actually drop this variable. So now it will be fine. So I can see all the variables are at the top of the table. So now I can write down this command, drop year. So I actually drop this variable because for whatever reason the year is not coming in the right format. So instead I'll create one variable. Let's say year. So let's say I generate a variable gen year, and it is _n. And if I do that, I'll see in my stata I have actually created this variable. Oh, I actually had a variable time. I could have used that, but no problem. Now I have created a variable year, and it is 1, 2, 3, 4, so as per the sequence. So let's say this data is taken from 1951, let's say. So what I will do, I will simply add year is equal to year plus 1950. So I'll get the values here, assign the values year equal to year is equal to year plus 1950. Now if I go back there, so I'll see my year has started from 1951 because I've added 1950 to all of these. Now what I'll do, I need to bring the year as the first column because that is the time and I want to see it. So what I'll do is I will write this command, order year. So this is the basic cosmetics we need to do as a part of the data pre-processing. So I got my year here. Okay, so now I got my exactly the kind of table I was looking for. Now you want to visualize autocorrelation here. So how do I visualize autocorrelation? So essentially to visualize autocorrelation, I need to get the residual term, right? So we know we need to get the U hat term. So how do I get the U hat term? I have to first define the regression equation. Okay, so I can get U hat term. So let's say, a very basic regression model I'm going to write. I'm writing consumption as a function of income and wealth. So consumption is my dependent variable. Income and wealth are my independent variables. So of course, if my income is increasing, it is likely that my consumption will increase. And if I have a lot of wealth, so which are already there as stock variable, if I already have a lot of wealth, so it is likely that my consumption would be higher. Okay, so in both the cases, the variables are likely to influence my consumption positively. So if I just simply write down this equation, regress consumption, and my independent variable is income and wealth. So if I do this, so I get a nice regression equation. I get R square value It's 0.99. I mean, nothing can be better than this. Okay, adjusted R square value is also pretty good. I have 54 observations. Now I have to check if my model has some problem with autocorrelation or not. So let me actually, so how we do that? We have to basically look at the U hat. We have to estimate the U hat, the error term, and from there we will actually get if we plot the U hat, we will actually get, if there is any sort of correlation among the error terms, and if there is some sort of relationship among the error terms, so we will find that, there is a autocorrelation present in my model. So how would I do that? So essentially I would write predict, let's say I define a variable U hat, and U hat is basically residual. So state understands this command, recede or residual, whatever you write. So if I write this, so I get the U hat. So I got my predicted U hat. Now if I plot U hat, so if I plot U hat, of course I have to give time. Let's plot U hat against what? So if I plot U hat with year, so my time variable here is year. So then I see that there is a lovely sort of graph appearing, and I can see that it looks like there might be some pattern because it is narrow at the beginning and there is expanding, and there could be some sort of pattern, but we have to still see. Perhaps I should plot a line. So how we do it instead is two-way line. I think this is the command, line, and then we will write U hat, and we had year, right? So if I write this, yeah, Stat has taken this command. So we will see the line, exactly that what we were looking for. We got a beautiful sort of plot where you can see that the error terms of every period are actually sort of, there's some sort of relationship. So every period, so first in 1950, it is gradually declining till 1970, and then slightly peak, they started picking up, then sudden fall, and then again some spikes, and continuously it is expanding. The error term is continuously expanding. So it is quite likely that there would be some sort of autocorrelation structure present in my model. So there are some correlations in the error terms, and there is autocorrelation present in my model. Okay, so that is how we see in Stata, if this data set, how do we visualize looking at the residual plot. Now let us go to R. Okay, so I was actually doing this a little bit. So how we do it in R? So we need to run the working directory. So I got my working directory is already fixed here, so I don't have to set it. Then for reading Excel file, I need to run this command read Excel, and I have already loaded this data set in my R. So I can just give a name, US consumption, and that is basically the name of the data set. So my R program will actually recognize whenever I write US consumption to be the exact data set I have, because in my R program you can see there are many files open, right? So I need to tell which exact file I'm talking about. So US consumption is the name of the file. I'm basically giving this name, and if I run it, so it has actually recognized the file. Now I will actually copy some of the codes I was writing. So let's say I want to again, let's say we want to visualize, and I think there is some problem with the time variable, year variable. So again, what I'm going to do is I'm going to create a variable called time, just like before, and what I'll do is I will let's say, or I actually created this variable, so let's not just waste time on this part. So I actually had this time variable here. So this time, so I had this 1, 2, 3, 4 up to 54 because I had 54 observation. So what I'm going to do is I'm simply going to just a second, there's too many R files open here. Okay, I'm simply going to write. So since it is 1, 2, 3, 4, I want to give it a exact year. So I can write US consumption time is equal to, so we use an arrow sign in R is equal to US consumption plus, let's say, 1950. Okay. So if I write that, so essentially it will take the value from 1951. Okay, that's what it should do. All right. Now, once I have my year data ready with me, so what I'll do, like previously, like we did previously, so I need to run a regression here also. And if I want to run a regression, I need to install a package called lmtest. Okay, so I'm just copy pasting instead of typing down all the codes. So if I install this lmtest package, so this package you need in order to run a regression or doing econometric sort of activities. So once you install it, you have to load it, and when you have to load it, you need to write library the same lmtest. Okay, so R has completed downloading the package. Now I can run this. So R has actually loaded it. Now I'll run a regression. I'll simply run a regression like I did just now using Stata. So I'm just going to name a model. Let's say I have named this as MOD model, and the model is essentially I am running a regression equation where my dependent variable is consumption, just like before, and my two independent variable income and wealth, right? So if I do that and if I run it, I get my regression equation. I get my regression done. Now, in order to visualize, unlike Stata, you have to actually write a command. So if you can write print, so it will give the summary of the model, or you can actually write the summary. It will actually provide you the details of the model. So let us write down both. So it has given the coefficients, and if you run the summary code, so then you will get all the coefficients, the p-value, standard error, the value of the t-statistic, as well as the r-square, adjust r-square, and everything that you need in a regression equation. So like before, you again want to understand how the error terms are related, and in R is really simple. So all you have to do, R again, like Stata, R also understand the residual. So plot, so basically in this case, I have to write down the residual of this model, right? So essentially I have to write the resid resid model command. So plot resid model, and if I plot it, I will see something like this, exactly the same data. So of course the way the points will be scattered will be same. And if I want to get a line or something, so in that case I have to write something like a type. Okay, so plot resid type is equal to O. So there are different types. You just check it in the internet. So there are, you can get L, H, S for step function and so forth. So for different output, you can actually sort of give a command to R what type of plot you want to see. So here I wanted to see a line plot. So I have given this command O, and I got how the points are actually connected. So essentially the same thing we have seen in Stata, we can see in R. So essentially this is how you, by plotting the error terms, you can actually see the structure, if there is any structure of autocorrelation present in your model. And it is advisable, before even you do the test, Durbin-Watson test or Bruce-Godfrey test, it is advisable that if you suspect that your model has autocorrelation, it is always advisable that you actually plot the residuals to see if the autocorrelations are present or not. Okay. So with this, I'll end this lecture here. And in the next lecture, we are actually going to use the same data set to see if there are Durbin-Watson. We basically will run Durbin-Watson test. We will also run Bruce-Godfrey test. And then we'll talk about how to actually get rid of the autocorrelation problem which we have. Thank you.